This is a walkthrough of Problem 1 on Exam 1 of Module 4 in the book Problem Solving Guide for Mechanics and Thermodynamics. Physicists, or maybe I should say astronomers, can determine the mass of planets by observing the period of their moons. The heavier the planet, the greater the gravitational force on the moon, and the greater the orbital speed. Phobos, a moon of the planet Mars, takes 7.66 hours to complete one orbit. Phobos is the closest moon to its planet in our solar system, and since it's so close, it has a short orbital time. The radius of its orbit is 9380 kilometers. Determine the mass of Mars in units of kilograms based on these data. How are we going to start this problem? Well, I know. A good diagram. There it is. Phobos going around Mars, only one force on it, the gravitational force. So what is the force of gravity from Mars? Newton's law of gravitation is G m1 m2 over r squared. The gravitational force between two objects is Newton's gravitational constant times their masses divided by the distance between them squared. It's the only force on Phobos, so that's ma of Phobos. Sum of the forces is ma. That's G m1 m2 over r squared. We got three m's in there. We got m, m1, and m2. m1 and m2 are Phobos and Mars, and the m and ma is the mass of Phobos, right? Because that's the sum of the forces on Phobos is the mass of Phobos times the acceleration of Phobos. That's what F equals ma means. So the mass of Phobos is in both sides. It cancels. And we have Mars left. So the acceleration is Newton's gravitational constant times the mass of Mars divided by the distance between them squared. We have the radius of the orbit, converting that to meters, 9.38 times 10 to the 6 meters. We have Newton's gravitational constant. We can look it up. You can ask the teacher. 6.67 times 10 to the minus 11th Newton meters squared per kilogram squared. We can substitute these in, and we get that, but two unknowns. What do we do now? The acceleration is v squared over r, and so we just plug in v squared r for the acceleration, and we can get v from the orbital data. It takes 7.66 hours to go around once, one complete orbit. That's 2 pi r, the circumference, and we have r. So we convert the time for one revolution to seconds, and we get the distance over time. That's the speed, distance over time. 2.137 kilometers every second. So we put this in for the speed, and we put the radius in, v squared over r, and the only unknown we have is the mass of Mars. So we just got to do some calculator work, and we get 6.4 times 10 to the 23rd kilograms. I had to look that up on Google. Google says that. 6.39 times 10 to the 23rd, and that is good enough for me. That's problem 1.